What's the difference between a document or a representation and a model?
We have to make the distinction between a document that is text-based and a living document, which is the model. So natural language has evolved over thousands of years, and it's very rich and it's very subtle, but the problem with it is that it cannot be verified formally. When you use natural language to specify standards, there is no way to verify that the standard is complete, lacks contradictions, and is clear. Consistency means that the facts expressed either by the model or by the text document are coherent, they go hand in hand. This is one of the big benefits of modeling. There is no way that someone reading the document will remember, oh, page 7 they say this, now at page 375 they say the opposite. Whereas if this is put into a model, the model will be able to catch this. The model will shout, quote unquote.
Can you tell me what it means to be complete, to develop a representation that is complete, and how do I check this?
Intuitively, completeness means you ask yourself, if I give this model downstream to the people who actually have to build and implement it, do they have enough information so that they don't come back to me and ask too many questions, or ideally no questions at all? But the downstream people, they have to have their leeway for their design decisions. So if you are the system architect, you may be satisfied with providing the first 3, 4, 5 levels of detail and let the engineering disciplines interact with each other, where the conceptual model really serves as the neutral platform through which everybody can communicate their ideas and their designs.
Any other attributes that I should be aware of?
Yeah, elegant.
Okay.
Ultimately, elegance is what we want our product or system to be. So if you have an elegant model, it is highly likely that your product at least has a chance of being elegant. If your model is ugly and convoluted, that makes it really hard to come up with a good, elegant solution to the problem.
Yep. Can you tell me a little bit about why companies build diagrams?
The idea is to capitalize on the fact that humans are primarily visual creatures. Normally, when I want to show you something, I'm not going to take a pad of paper and write sentences. I'd rather draw boxes and circles and start to connect them with lines, with arrows. Diagramming is really informal model-based systems engineering. We can formalize the way this diagramming is done by giving precise semantics to the various symbols and the links among them. One of the benefits of model-based systems engineering is that you don't only model the sunny day scenario, or what we call the nominal model, where everything works fine and as expected. This, as a rule of thumb, is only 20% of the design. The rest of the 80% is what happens in various situations where there are contingencies, or worse yet, emergencies. One of the works I've been doing recently is to model the 3 Mile Island accident. We started with the nominal model of the reactor of the particular type that was there. And of course, the model ran and we did the simulation, everything runs fine. Then we read the step-by-step description of what went wrong with the reactor. The PORV relief valve got stuck open. And as a result, because there was no cooling water, all the cooling water of the core started to heat. And because it was heating, there was an automated system that started to flow emergency water to cool it. However, the people who were operating and were sitting in another building, they couldn't see what happened to the valve. But what they got as a report by the instruments that were monitoring that were inaccurate, that the valve got stuck closed. Your feedback is the opposite. And so they were thinking that there is a flooding of cooling water. So they stopped the emergency water and they actually determined the fate of the nuclear reactor. And this is a result of the wrong signal that they got from the system. We call it a cyber-physical gap. The gap between what happens out there in the real life and what the people operating it have in their mind, the mental model that they have of the real state. And if there is a mismatch, they make decisions that can worsen emergencies. When you design a system, if you can come up with such scenarios that your feedback is inaccurate, then you can say, okay, I will put in not one way of monitoring it, but three. So if they are contradicting, at least two of them will say something and the other will say the opposite. I'll go for the two. By having a model of the nominal system as a starting point, you can incorporate devices that can handle what can go wrong.